Hello, my name is Mirul. And
I am Akram.
Hi, I'm Tanusha.
Hello, my name is Lily.
And we want to introduce our topic about advanced counting.
Techniques.
Okay, later we will show you some videos that will introduce you some ways that will improve your mathematics discretes. Okay?
Yeah.
Okay, so now I want to introduce you about the recurrence relation in mathematics discretes. How to apply the recurrence relation in mathematics discrete for something that we don't know. So now we should know that the n is the sequence ordering number that started from the zero number 1, 2 and will become increasing order. But we don't know which the number is the end of the ordering recurrence of relation. So now we did not simply take the final result of the answer that what is the n number. No, we just take the formula. For such, I can give you some example that when I want to do a push-up for today, that 10 times. So I think I want to double times for next day. So for the next third day, I will double it from the second day that I want to do. So we know that on the first day I want to do 10 push-up. For the second day I want to double it, becomes 20, and I want to double it, becomes 40 for the third day, and so on. So we can conclude that n is the ordering number from 0, 1, 2 and 3 and so on. But I want to say that we can conclude that A is the representation of push-up, but n is the day. So we can say that A0, A1, A2, A3, that is AN. What is AN? AN is functions that we can say A is a push-up time, N is a how many times we do push-up for a day. For example, when I started from 0, that is when I begin with first day, that is A0 equals to 10 times I do push-up. So for A1 is the second day, that is double time. So 20 times, 40 times for A2, A3 and so on. So that is the topic that I want to think and tell about it. Thank you.
Counting bit strings. Find the recurrence relation and give initial conditions for the number of bit strings of length n without two consecutive zeros. How many such bit strings are there of length 5? Let n denote the number of bit strings of length n without two consecutive zeros. To obtain a recurrence relation for an, note that the number of bit strings of length n that do not have two consecutive zeros is the number of bit strings ending with a 0 plus the number of such bit strings ending with A1. Now, assume that n is greater than 3. The bit strings of length n ending with 1 without two consecutive zeros are the bit strings of length n minus 1 with no two consecutive zeros with A1 at the end. Hence, there are an minus 1 such bit strings. The bit strings of length n ending with 0 without two consecutive zeros are the bit string of length n negative 2 with no two consecutive zeros with 10 at the end. Hence, there are an minus 2 such bit strings. We conclude that an equals to an minus 1 plus an minus 2 for n is greater than 3. The initial conditions are a1 equals to 2 since both the bit strings 0 and 1 do not have consecutive zeros. A2 equals to 3 since the bit strings 0, 1, 1, 0 and 1, 1 do not have consecutive zeros, while 0, 0 does. To obtain A5, we use the recurrence relation 3 times to find that A3 equals to A2 plus 1 equals to 5, A4 equals to A3 plus A2 equals to 5 plus 3 equals to A, A5 equals to A4 plus A3 equals to A plus 5 equals to 13. Note that AN satisfies the same recurrence relation as the Fibonacci sequence. Since A1 equals to F3 and A2 equals to F4, we conclude that AN equals to Fn plus 2. Thank you.
Divide and conquer algorithmic paradigm definition. The divide and conquer algorithm works by first dividing a problem into a one or more instance of the same problem of smaller size and then conquering the problem using the solution of the smaller problem to find a solution of the original problem. Example, binary search covered in chapter 3 and 5. It's worked by comparing the element to be located to the middle element. The original list is the split into two lists and the search continues recursively in the appropriate sublist. Merge sort convert in chapter 5. A list is split into two approximately equal size sublists, each recursively sort by merge sort. Sorting is done by successively merging pair of lists. Divide and conquer is recurrence relation. Suppose that a recursive algorithm divides a problem of size n into a subproblem. Assume each subproblem is of size n per bit. Suppose g and extra operations are needed in the conquer step. Then Fn represents the number of operations to solve a problem of size and satisfy of the following recurrent.
Hi guys, today I'm gonna teach you about the Fibonacci number. Actually, this one is the small topic about advanced counting. So today we're gonna learn Fibonacci number. Actually, Fibonacci number is actually the small topic that it is interesting and interesting. So it starts with 0 and 1. So what number here you're gonna find is add two number before to get the number here. So which is 0 plus 1 equals to 1. And repeat the same step to get the next number. Here is 1 plus 1. So it's 2. So we do it again for the next one. You're gonna add up first two number to get the next number. 1 plus 2 equals to 3. So this one is actually the really small topic about the Fibonacci number. Easy, right? So now I'm gonna give you the example how you apply the Fibonacci number. So I'm gonna give you the example like rabbit. Yeah, rabbit. So rabbit like this. So you're gonna count in every month or in the next month how many pairs of the rabbit will be produced. So you're gonna count like let n be the month. For the next, xn will be the pairs of the rabbit will be produced. So how do you apply the Fibonacci number in your daily life? So how do we count the rabbit, how many pairs of rabbit will be produced every month? So to make it easy, we can make a table. So n upper here, and the pairs of the rabbit will be produced will be put under the table. So 0 month, first month, second month, and third month. This will be the month. Okay, for the 0 month, impossible you will produce any pairs of rabbit, right? So here will be 0. First month, maybe we will produce 1 pairs of rabbit on the first month. So we put 1 here. To get the pairs, the number of pairs at the second month, you're gonna plus 0 and 1 together. We'll get 1 pairs of the rabbit at the second month. So we repeat the step. At the third month, it's actually 1 plus 1. So third month will be produce 2 pairs of rabbit. So is that easy, right? So that's all. Thank you.
Okay, that is for our conclusion on this topic for recurrence relation for advanced counting technique. So if you, I hope that you can understand our solutions that will provide your help. So thank you. Okay, and goodbye.
Bye.
Masuk. Hello, my name is Mirul. And
Hello, my name is Tanusha. Hi, my name is Amimi.
Serentak pula. Okay, start.
okay, this video I will introduce that the relation
Mula.
Okay, this video I will introduce you about the recurrence relation in mathematics history. What is recurrence relation mean? It is because it is right.
Divide and current recent research pada bungkus.
Today I'm gonna teach you about the
Ulang lagi.